All right, so let's talk about bytes and files. And by the way, if the previous servers are not responding, just skip that networking stuff and come to here, because this one can handle any number of users with no problem. So let's try this one. Right here, I have my Python in immediate mode, so I can take an integer and print its type. You do have to learn your variable types. I spend a lot of time in Python converting from one type to another. So if you set, Python is a weakly typed language. C is a strongly typed language. Every variable you use, you must first define exactly what kind of data is stored in that variable. And that's kind of a lot of work, but it makes things a lot cleaner. However, for better or worse, Python is a weakly typed language. So if I say I equals 1, it guesses what kind of variable I want from what I put here. So that's an integer. It decides to make it an integer. If I add 1 to it, it's still an integer. Okay, now you can store bytes. So if I do this, I say B \x01. That is the way to refer to the 8-bit byte containing 1. And a B makes it a byte object. So if I store that, now it's class bytes. So that is a new data type that is not present in Python 2. And if you try to add 1 to it, you can't. It is not an integer that you can add something to. It is a byte object. And in fact, it's immutable. Can't be changed once you define it. You have to redefine it to be something else. You can't do any kind of math on it. So let's try some of these. Now I've created A, which was a single byte object, and it really is a byte array. You can refer to its location as A bracket 0. And now the contents at that location are in fact an integer. So now you can take the value of it and put it in an integer variable, which will now be an integer, and now you can add 1 to it. So byte values are different than integers. So this, all took me a while to get over my thinking from old systems. I thought that a string is just a series of bytes, and bytes are just integers and you can add to them. And I had all kinds of techniques doing this, and you have to get that out of your mind in Python 3. The strings are totally different. Then there are byte arrays, and then there are integers, and they're different data structures. So this is the more modern way to think. And after you get over rebelling and trying to do things the old way, you really have more control over what you're doing here. So if I wanted to actually add 1 to a byte object, I'd have to do it this way. All right, so what happens here is here I define a byte object that contains 1. So it's a 1 with bytes. Now I take an integer object by reading the first content, the first element of that array or that byte object. And now I have a 1, which is an integer. So I can now add 1 to it, and I've created an integer. Now I don't change the old byte object, which by the way is immutable. I create a new byte object, C, D from C, and D is now an object of type bytes that contains 2. So I have done the addition, but it does require sort of going around in a circle to get things done. All right, let me get this out of here. So I exit from there. So let's make a file here. I want to make a file in file, so nano in file. And I put in there hello. And now I make this program, which is going to be, say, read file. .py. All right, so this is how you open something. You have a with statement, which will open it. This is the name of the file. This is the type of access. I'm going to read bytes. And here's the file pointer, F. This is kind of nice. You have a colon and you have a block of code. And when you exit that block of code, it'll automatically close the file for you. So that's pretty nice. So now I'm going to read a byte. And while the byte is not equal to empty, I'm going to print it and then try to read the next one. So this will just read it to the end, printing out every byte that appears. It's a simple way to do that. So if I run that one, Python 3 read file, all right, it reads the bytes one by one and prints them, and they are all byte objects. I didn't say what to interpret them as. I just said read one, and by default, it read them and turned them into byte objects and printed them out. All right. So now this one will make a copy of a file. So let's make that copy file.py. All right. So this is very similar to the last one. I open an in file to read, and then I open out file to write bytes. So that in file is F and the out file is G. So now I read a byte. While the byte is not empty, I print it and write it, and then read the next byte. So this should make a byte by byte copy of a file. So if I do Python, let's do directory ls-l to see what we've got. And I make my window bigger. All right. So we have in file that's 6 bytes long, and there is no out file. But if I run that thing, Python 3, copy file, it prints out this stuff. And now if I do ls-l, I now have out file, which is also 6 bytes long. So if I cat in file, it's hello. And if I cat out file, it's also hello. So that's good. Now you can just play games. Now you download this big file and find the bytes in there that are equal to 8. Count how many there are. It's got a lot of bytes in there, but only some of them are 8. Then here's 2 files. This is a simple kind of encryption, sort of like the Caesar cipher. There's 2 files. You have to add them byte by byte, and it will construct a flag. Here's 2 files you have to add, and it will make a binary image, flag.ping, and you have to open that in a viewer to see the flag. So these all let you practice those things. All right, I'm going to stop this recording.